And I apologize. I mean, it's not, there's nothing I can do about the way the day's fall and we have time and whatever. So it is what it is. But we are going to practice again today. And I ran off the rest of your practice tests, so here they are. I gave you the first one yesterday. Here are the other two. So we'll finish the first one and work on the second one today. Test out. Get that first one out. Let's get it wrapped up. We only have a little bit to go because we did awesome yesterday. Did everybody get this? Alright, so here we go. According to my records, we are ready for problem 15. Which is a trusty Venn diagram. And here we go. So this is one of our I like apples and bananas problem. And we know that the probability of liking apples is 0.7, bananas is 0.5. And what did we say yesterday about this? What does this mean? Both apples and bananas. That means both. And that actually is the only number that we can put directly into the Venn diagram. Sometimes kids will look at this and say, oh, 0.7. No, that 0.7 is the whole circle, not just that part. So start with that middle part. Now you can fill in the rest. Because if the whole circle is 0.7, then what's this? 0.4. And if this whole circle is 0.5, then this is 0.2. Now, I need you to look carefully. How much total do you have in that Venn diagram right now? 0.9. That's not enough. In a probability problem, you have to have 100%. So, if this is 90%, then there must be 10% out here, 0.1, right? Out here? So now we're ready to answer the question. Don't stop with your diagram until you got everybody accounted for, all 100%. All right, here we go. Question. What does this mean?
Apples and bananas.
That means I like apples, but not bananas. So I'm in the A circle, but I am not in the B circle. So isn't that right here? So that answer is 0.4. What does this mean?
Apples and not bananas.
I don't like either one, so that is these guys. All right, last page, last problem. So when we did these in our notes, these were the M&Ms. Remember, we picked out M&Ms by color. Now we've got 2 classrooms of kids, and we'd ask them, what's your favorite subject? Okay. You should have another page, isn't there another page? Yeah.
On the first.
So, yep, on the first test, there's that side. All right, so, question A says, what is the probability that if I pick one kid out of each class, that they both will be math? So in other words, math and math. What would that be? Math and math. What's the answer? 0.24. Very, very good. How did he get 0.24? He multiplied 0.6 times 0.4. Why did he do that? Because and means multiply. So math 0.6, math 0.4, multiply them 0.24. What's the probability the first likes math but the second likes science.
Use NPR.
No, just pick them right out of your chart. So it's gonna be 0.6 times 0.2. So the probability that I pick a kid who likes math out of the first class is 0.6. And then I'm getting a science out of the second class, that's 0.2. I just multiply those, 0.12. Please use your calculator if you're not good at that multiplication. 0.12 would be the answer. What's the probability that I pick one out of each class and I don't get an art? So no art.
90.
0.9 times 0.9, which is 0.81. Kids, not art means everybody but art. So do you understand where the 0.9s are coming from? Now D is tricky. Last one's tricky. What's the probability that one will like science and the other will like English? What's tricky about this?
Doesn't specify.
Doesn't specify order. So it could be science and English, or it could be English and science. Do you all understand that from reading the problem? It's different than question B. Question B says the first one likes math and the second one likes science, period. This is I need one of each, but I don't care who's who. So, first class, second class, here we go. Science and means times English. I got 0.03 for that one. Or English first, so 0.2, and science second, 0.2. I got 0.04 for that one. Now, what do I do with those two numbers? Since it's this or this, I add them. So the answer is 0.07. Okay? All right, practice test 2. Here we go. Answer the following, use your calculator to evaluate, round to the nearest thousand if necessary. Okay. How many different sandwiches are possible if there are 3 kinds of meat, 3 kinds of bread, 2 kinds of meat, and 4 kinds of cheese? A sandwich must have bread, meat, and cheese. What'd you say?
3 times 2 times 4.
Yes! This is exactly like the shirt and pants problem we did yesterday. Do you remember? Going to the closet, picking a pair of pants and picking a shirt? This is exactly what you're doing. You're picking a bread, picking a meat, picking a cheese. So Eli says, all right, I have 3 kinds of bread, 2 kinds of meat, 4 kinds of cheese. The answer to the problem is 24. There are 24 different kinds of sandwiches possible. Okay? Do not put factorials in that problem. We're not arranging this stuff. We're just picking. How many ways can 10 different chairs be arranged in a row? 10 factorial. 10 things in a row is 10 factorial. What about 10 things in a circle? 9 factorial. All right, I don't know what 10 factorial is by heart. I should know that probably, but I don't. I got 3,628,800. That's the answer to question number 2. Every person in this room should be typing with them, because test day is going to come, and you're going to say, oh, this is what I forget how to do this, and I'm going to look at you and smile. I'm not going to help you with your calculator. And your calculator is going to give you the answer. How many ways can you answer 5 multiple choice questions if each question has 4 options. So 5 multiple choice questions, A, B, C, D. What would that look like, Jacob?
4 to the 5th power.
4 to the 5th power, he's exactly right. Because I have 4 choices for question 1, and 4, and 4, and 4, and 4. And these are all getting multiplied. And he said, easier way to think about that is 4 to the 5th, 10/24. How many ways can I give away 4 identical blue markers to 4 students in a class of 12?
12C4.
Yes. Why is this 12C4, Jacob?
Because it's all the same.
They're all the same. So if you're all gonna get blue markers, do you care if you get the first one or the second one? No, it doesn't matter. They're all the same. What if I'm giving away a $1 bill, a $5 bill, and a $20 bill? Do you care? Yeah, then the order would matter, right? When the gifts are different, order matters. When the gifts are the same, doesn't matter. Okay, what's 10 or 12C4? Anybody figure that out yet?
495.
495. How many 10-letter words can be formed from the word toothpaste? All right, now be careful. What do I start with? 10 factorial. However many letters you got, however many, count them. That's what you start with. So 10 factorial. Now, why am I putting this division in here? What have I noticed about my word? There are repeat letters. So let's see. It looks like I have 3 T's. So that's 3 factorial for the T's. You divide by each duplicate factorial. Looks like I got a couple of O's. Anything else? That's it. When you type this in, make sure that's in parentheses. Please don't try to combine these. You can't. Just type it in. Did you get 302,400? How many ways can 5 people be seated around the dining room table? 4 factorial, which is 24. So one more time, at the risk of boring you, which I know I would never do. 6 people in a row is 6 factorial. 6 people in a circle is 5 factorial. How many teams consisting of 2 seniors and 3 juniors can be formed from a group of 8 seniors, 6 juniors, and I am picking 2 seniors and 3 juniors? All right, so what do you think? 8C2, I love it. 6C3. And what am I going to do with those 2 numbers? Am I picking seniors or juniors? Or am I picking seniors and juniors? And if it's and, no. And Why is he using C's and not P's? Order doesn't matter. I'm picking these people for a committee. They don't care whether I pick first or second, they just want to get picked. They want to be part of the committee. I got 560. Is that right?
Yeah.
Melissa, you with us? Okay. All right, number 8. What is the probability of being dealt a 4-card hand that's all hearts? Oh no, excuse me, all red, all red. So I want a 4-card hand that's all red. What, Eli?
52 C26 over 4 C4. 52 C4.
52C26 over 4.
52 C4. Is it first? Yeah, 52 C4.
Okay, I totally love the denominator. The denominator's perfect. Why is the denominator 52C4?
52 cards.
52 cards, and I'm picking 4 this time. It's a 4-card hand. Now, what is his numerator? The way that's written, what is that telling me? There are 52 cards, and I am picking 26 of them? Is that what's happening? No, this is a 4-card hand. I'm picking 4 cards. But I'm picking them from the 26 reds. So the numerator is 26 C4. Remember, this first number is your pile of potentials. If you want red cards, then that's going to be a 26. Now, please don't try to cancel it. No, just divide it out. You can't do any kind of crazy simplification. I got 0.0552. So if we put that in common language, you have about a 5% chance of getting all red. Where am I? 5-card hand with exactly 2 queens. Oh wait, 4-card hand. I'm having a hard time reading. So my denominator is 52C4. Now what's your numerator? This time we want exactly 2 queens. So think about that. What does that mean? That means I want 2 queens and 2 of something else? 4 cards. So 2 queens, 2 something else. All right, how do I get 2 queens? 4 C2. Remember, that first number is your potential. How many potential queens are there? 4. And you're going to pick 2 of them. Now, how many potential other cards are there? 48. And I want 2 of them. And since I want 2 and 2, I'm going to multiply that numerator. Kids, right?
Yeah.
So here we go. I got 0.025 basically. Anybody match that? Perfect. Perfect, perfect, perfect. Oops. All right, that was 2 queens. All right, number 10, let's look at that one. That one looks a little bigger. Let's read through it and choose a strategy. What do you think? That's gonna be a tree diagram. What are the 2 activities in the problem? Popcorn and soda. question is, find the probability that they'll serve soda. So that means our tree diagram is gonna start with popcorn or no popcorn. Please read the problem and make sure that makes sense to you. Why I'm starting with popcorn. It hinges on the question. The question says find the probability of soda. So soda comes last. Now I'm gonna put some numbers in. And what do I remember about each V? Each V adds up to 1, right? Each V adds up to 1. So here we go. If we serve popcorn, there's a 90% chance we'll serve soda. So right there, 0.90 or 0.9. You don't need the 0 if you don't want it. As soon as I put a 0.90 there, I'm gonna put 0.10 here. If they don't serve popcorn, there's a 45% chance. Okay, it's real easy to sit here and copy down what I'm doing. Are you following this? You need to be able to do this on your own. What does our test look like? This. Find the probability that they'll serve soda if they serve popcorn twice each week. Now, I didn't clarify that, a school week. This is our school cafeteria. So twice each school week would be what fraction or what percent? 2/5? So you can either put 2/5, or you can put the decimal for 2 divided by 5, which is 0.4. What's the probability we'll serve soda? So we need this branch right here, right? And we need this branch right here. So what do we do? 0.4 times 0.9. 0.6 times 0.45. And then what do we do with these two answers? Add them, because we're either going to serve soda this way or we're going to serve soda that way. So 0.4 times 0.9 plus 0.6 times 0.45. I got 0.63. What you got? All right, read question 11. What you got? What? A Venn diagram, you mean, the circles?
Yeah.
Yep, you're exactly right. That's exactly right. Good job, Olivia. The reason she's saying Venn diagram is because she sees two groups of people doing some stuff and overlapping. We got people teaching and we have people nursing. There's 60 of them altogether. Everybody does one or the other, so there's nobody out here. Everybody's in the circles. 40 of them like to teach. 35 of them like to nurse. Well, I know it's after lunch, but if your brain's engaged here, you notice a problem. How much is that? 75. And how many people are on the bus? 60. So that means you got extras? So what are those extras doing? Both? How many are there? 15. So right here in the middle goes the 15. We start in the middle with the overlap. Now, if the whole teaching circle is 15, excuse me, is 40, then this part of it has to be 25, because 15 already in there. And then with nursing, this has to be 20. What's the question? Only nursing, so only nursing would be 20. Kids, you gotta develop a feel for how to set up the problem. So like this one felt like a tree diagram. This one needs to feel like a Venn diagram. Okay, now we have our expansion problem. Now we just went through this yesterday, so hopefully you remember the steps you have to follow. Okay. You know, I was talking to a parent the other day, and he said, you know, my kid kind of knows what's going on, but can't ever remember what to do what in each problem, and that's just practice. It's just practice, trying to do it over and over and over again. So, in a problem like this, what are the steps that I need to go through in order to answer this? Expand means write it out. So this is one of these big ones. It's gonna go across the board. What do I start with? The Pascal's triangle, the pyramid of numbers, what, you've got a creative ways to think about it, Olivia, it's all good. The pyramid of numbers, right? Pascal's triangle. So, Pascal's triangle starts with a 1 and a 1, and then remember the middle terms are the sum. So 1 and 1, and then add these, 1 and 1. So what's here? 4, 6. Yep, you got it. Let's do one more row. And remember, always start and end with a 1. Now, in this particular problem, because we're going to the 4th power, I need the 1, 2, 3, 4th row. So I write those numbers down. 1, 4, 6, 4, 1. That's step 1 of the problem. Get your numbers written down. Need to go see the nurse? No. Okay. Stand up if you need to. All right, now what? What's the second step once we get our numbers written down? I put in the X's and Y's. Only in this case, I'm going to put in a 2X and a 3Y. So in parentheses, 2X and 3Y next to each of my numbers. By the way, now that I'm thinking about it, do I see you guys tomorrow?
No.
No, I don't. What is today? Tuesday. But I'll see you Thursday?
Yes.
So Thursday will be our last review day. If you want to take the test after school, if you're able to do that, you can stay after school and take it Thursday. If you don't want to wait over the long weekend to take it on Tuesday, that'll be fine with me. Okay, what happens next?
Exponents.
Now I put in my exponents, remembering that when I do this, the first term starts with that power. So 2x starts with 4, and then counts down. And then 3y does the same thing, go in the other direction. And always you can check yourself, because in each term, the exponent to add up to that number. You're done. Put pluses in here and start simplifying. It's ready to go. Remember that this whole thing is a multiplication. And anything to the 0 power is 1. So this I can disregard. I'm not going to let it confuse me. It's just a 1. So what do I have here for my first term?
2x.
Oh! What can I do to help you stop making that mistake? Not just you personally, but everybody collectively. It's not 2x to the 4th, it is
16x to the 4th.
16x to the 4th. Everything in the parentheses gets the exponent. Okay? Alright, what have I got here? Well, there's more here. You might need your calculator to help you. Because that's all multiplied. What am I multiplying? I'm multiplying a 4 and 8 and 3. So 4 times 8 times 3.
96.
96. And I still have my x cubed and my y. Don't forget about that. This is going to be 6 times 4 times, no idea what that is. What is that, 216?
Yep.
You do this one on your own. Got it?
216.
Another 216. X, y to the 3rd. Hey, now redeem yourselves. What's on the end? Remember, anything to the 0, just disregard it.
81.
What is that?
81.
Yes, 81 y to the 4th. Problem finished. Okay? There's a lot to that. It's easy, one step at a time. All right. Find the 5th term of x minus 2y to the 8th. Oh my goodness. So first of all, does this look like this?
Yes.
Yeah, they're basically the same problem. But this one's easier because it isn't asking you for all of these, it's asking you for just one of them, right? But you're gonna find that one you're looking for exactly the way you found these. So what did we start with? What did we start with? When we started this problem that we just finished, what was step 1? Write down the numbers, and the numbers came from the triangle, right? So here's my triangle. I need more of it. How do I know I need more of my triangle?
Exponent A.
It's to the 8th power, and this tells me which row to look at. So here we go. Numbers get big kind of fast. So I don't know, did I add right?
Yeah.
So there's the 8th row of the triangle. Now, kid, you know the test is gonna look just like this. So feel free on your test paper somewhere to write down the triangle. Now, I'm not gonna write down all these numbers though, because I'm not doing the whole thing. I want only the 5th term. So 1, 2, 3, 4, 5. I want the 70. Next to the 70 will go our x and y. In this case, it's an x and a negative 2y. X, negative 2y. When I put the exponents on, I just count down, right? So the first term, it would be x to the 8th, 7th, 6, 5, 4. So my x exponent is 4. I'm counting down from 8. 8, 7, 6, 5, 4. And as soon as I put a 4 on that one, I know this one is also a 4 because they gotta add up to 8. And now I simplify. This is all multiplication. There's no subtraction in there. Please don't have a minus in the middle of your problem. It's not a subtraction, it's a multiply. What am I multiplying? I'm multiplying 70 times this. And what's that? Negative 2 to the 4th power is?
That is. Yeah.
Not negative 16,
Positive 16.
positive 16. Remember, negative times negative is positive. So if you have negative 2, negative 2, negative 2, negative 2, these make a 4 and these make a 4, so your answer is 16 times 70, which is
1,120.
1,120, x to the 4th, y to the 4th. This is where what happened to the minus sign. Well, first of all, that's a negative, not a minus. And second of all, when you take a negative to an even power, it disappears. There's the answer to the question. Pay close attention, we are taking your test right now. All right, how would you calculate, am I on the right page? How would you calculate 9p5?
9 factorial, 4 factorial, and 5 factorial.
Now, that is 9c5. So when that's a c, you take the big number on top, then you subtract them and put the little number on the bottom. So a C problem has two things in the bottom. A P problem has only one thing in the bottom, and that one thing is the subtraction. So that's gonna be 4 factorial. All right, and that's just something you're gonna have to memorize. So the C has both things in the bottom. The P has only the subtraction in the bottom. Now, this is the answer to the question. I'm not done with it yet, but that's the setup. So 9, 8, 7, 6, 5. And then everything after that's gonna cancel with that. You can absolutely, I wanna see this work right here. I wanna see this canceling, but you can type that in on your calculator. I got 15,120. Now, guys, be warned, you get no credit for just writing this down. You have to show this work right here. And then if you need a calculator, go ahead and type it in. Sometimes enough stuff cancels that you don't need a calculator, but that one we did. Okay, I promise we'll finish this test and I'll shut up, all right? So let's get through it. Number 15, Venn diagram. So we have apples and bananas. Probability of apples is 0.65, bananas is 0.8. And one more time, what does this mean? Apples and bananas, and that's 0.55, and that's what I put into my chart first.
.45 outside the chart,
So point, oh wait,
maybe.
let's see, this is gonna be 0.10. Is that right? And this is gonna be 0.25. Check my subtraction, is that right? So how much is that all together? Is that 0.9, which means 0.1 out here? Now, I want everybody to get that. Okay, so look at that, look at those numbers. Don't just write them down. Do you understand where those numbers came from? Smaya? You understand where they came from?
Yes.
You got this.
Yeah.
Hands down.
Yep.
All right. Here are the questions then. Probability of not A and B. Remember, the hash means not. So in terms of apples and bananas, this means not apples, but yes bananas. So where am I in the chart if I'm a yes to bananas but a no to apples?
Banana circle.
Banana circle, but not the part of the banana circle that overlaps the apple circle. Just the banana, so 0.25. So the answer to this one is 0.25. What's this one mean? Neither one. I don't like apples. I'm not in the apple ball. I'm not in the banana ball. So I'm out here. What one? All right, here we go. Now we've got, okay, this is exactly like the one we just did. Am I looking at the wrong paper? I didn't even change the chart. The chart's exactly the same, but the questions are different. Question A. What's the probability that neither student likes science? 0.9 times 0.8. Look at the charts, guys. You take out the science, folks. You got 0.9 on the top, and the second chart would be 0.8. So what's the answer to problem A?
0.72.
0.72. What is the probability that the first one likes English and the second one likes math? So first one likes English, 0.2. Second one likes math, 0.4. What do I do with those? Multiply them. What do I get? 0.08. 0.08. Both like English. 0.2
0.06.
times 0.3. 0.06. And then one will like math and the other will like art. Okay, so math and art, or art and math. Okay, so what did you say, Olivia? Math first would be 0.6, and art is 0.1, so 0.06 for that group. And then art is 0.1, and math is 0.4, so 0.04 for that one. Add them together, I got 0.10. Everybody okay with that? All right, so I promised I'd stop at that point, and I will. Is there a homework you'd like us to crank out? I think we might be able to get our homework done. Huh? The second one? Yeah. Hurry up. All right. Let's look at the 9.3.2, the 9.3 number 2 homework. See if we can get that done for you. Okay, I'm looking at the 9.3 homework, number 2. That has a Venn diagram. And it talks about logarithms and trigonometry. And it looks like this. All right, how many like only logarithms? Look at the chart. How many like only logarithms? What did you say? 23. 23 like only logarithms. How many like only logs or only trig? 25. Don't make it hard, guys. It's so easy. How many like neither one? 6. Those are the losers. Okay, number 2, another Venn diagram. We got apples and bananas. And we know that apples is 0.5, bananas is 0.6, and apples and bananas is 0.3, that's our center one. This is going to be a test question too, so it's good for practicing it. So what goes here where I'm pointing? 0.2? Because the whole apple circle is 0.5. What goes here? 0.3, perfect. Now how much is that totaling? That's only 0.8, so there's another 0.2 out here? Agreed? Answer the questions. First one says probability of apples and not bananas. What's the answer? Apples and not bananas. It's these guys right here. There's a couple 0.2s in the picture, but it's that 0.2 right there. And then not apples and not bananas. That would be this 0.2. They just happen to both be 0.2s. All right, let's get the last one done. What's going to be our strategy with number 3? It's going to be a tree diagram. Absolutely it is. What are the 2 things? Not popcorn and soda or noodles and salad. What is it? Lunch and pre-calculus? What's the question? Find the probability that he buys lunch. So we're going to start with pre-cal or no pre-cal. I can't even imagine that existence, but pre-cal and no pre-cal. And then lunch and no lunch. All right, the probability, okay, is this okay with everybody? Okay. The probability that a student buys lunch at school is 34% if he takes pre-calculus. So if he's a pre-calculus, buying lunch is 34, and not buying lunch is 66 then. The probability that he buys lunch is 76 if he doesn't take pre-calculus. The probability that a student takes pre-calculus is 89%. Do all those numbers mesh with you? What's the probability he buys lunch at school? So we want this branch and this branch. Every one of our examples has been find the probability he buys lunch. I could just as easily say what's the probability he doesn't buy lunch, and then you would be looking at this branch and this branch, right? It would work exactly the same way. All right, so 0.89 times 0.34 plus 0.11 times 0.76. So I multiply the branch, and then add them up. I got 0.3862. So there's about a 38.62% chance that they'll go to lunch at school. All right, so if you are here today, you do not turn that homework in, please do not turn it in, because then I get all confused.
Oh,